Good morning, and thank you for joining us for Aeva's 2022 Product and Technology Day. We're thrilled to have you with us as we share some exciting developments from the team at Aeva. My name is Michael Oldenburg, and I'm the head of communications. I'll be your host throughout today's event as we hear from leaders across the company. At Aeva, our mission is to bring the next wave of perception technology to a broad range of applications, from automated driving to industrial robotics, consumer electronics, consumer health, security, and beyond. Because of their unique capabilities, our LiDAR sensors allow autonomous machines like vehicles and robots to make more intelligent and safe decisions. And today, LiDAR is about to take a big leap forward. To tell you more, here are our co-founders, Chief Executive Officer Soroush Salehian and Chief Technology Officer Mina Rezk.
We are entering a new era of industry powered by automation. Devices of all kinds, from vehicles to robots, are evolving into smart machines that can interact with the world using highly accurate sensors that are capable of seeing everything around them. A key sensing and perception technology at the heart of this is LiDAR, and we believe it's the fundamental tech that will power the next industrial revolution of autonomy.
We started Aeva 5 years ago because we saw this revolution come and understood the limitations of decades-old legacy 3D LiDAR system. That's why we are developing the next generations of LiDAR sensors with our unique FMCW, or frequency modulated continuous wave technology.
Aeva sensors go beyond the capabilities of legacy 3D LiDARs, constructing a detailed view of the world that includes 3D position and the crucial ability to detect the instant velocity for each pixel, delivering a new fourth dimension to perception. We call this disruptive technology 4D LiDAR, and we believe it's going to be as transformative to automation as the transition from black and white to color. Our 4D LiDAR allows autonomous machines, including vehicles and robots, to accurately perceive where things are and understand precisely how fast they're moving, delivering new perception capabilities that surpass what is achievable with traditional sensors, including cameras, radars, and today's legacy 3D LiDAR sensors. This additional layer of velocity data allows vehicles and robots to better understand the world and make more intelligent and safer decisions with higher confidence.
Importantly, we also created the world's first LiDAR module that fits all key LiDAR components, the transmitters, the optics, and receivers, onto one small silicon chip using silicon photonics technology that is proven in the telecom industry. This breakthrough in engineering allows for unprecedented miniaturization to enable new cutting-edge use cases for sensing and perception. It also allows us to manufacture this LiDAR chip module at mass scale, up to millions of units, to achieve the cost targets automotive OEMs and other volume customer need for production.
In 2021, we completed the third generation design of our LiDAR chip module and established a manufacturing partnership with Fabrinet, one of the leaders in precision optical and electronic manufacturers in the world. Importantly, this partnership allows us to deliver mass production volumes at their automotive qualified facility. And for the first time, we're using this LiDAR chip module to power our Aeries line of sensors, starting with our newest sensor, Aeries II, a highly versatile automotive-grade 4D LiDAR sensor built from the ground up to enable the next wave of autonomy.
Everything you think you know about LiDAR is about to change. At Aeva, we're making the impossible possible by fitting traditional LiDAR components onto one tiny piece of silicon with the world's first LiDAR-on-chip design. This new module is core to every product we produce, and it's the engine powering our newest sensor, Aeries II. We're revolutionizing LiDAR, taking high-performance sensing into the fourth dimension. Because Aeries II doesn't just measure an object's position. Continuous low-power beams instantly detect velocity, accurately identify where everything is, and help predict where it's going. With a wide range of placement options and multiple field-of-view configurations, Aeries II is our most versatile sensor yet, delivering an unmatched detection range of 500 meters with zero optical interference from sunlight or other LiDAR sensors. Aeries II is designed for automotive and beyond, Its rugged and compact form ensures peak performance no matter the conditions. We built Aeries II from the ground up to be automotive grade and ready for production. To meet the needs of innovators so that autonomy becomes a reality. Not tomorrow, today. Powered by the all-new Aeries II from Aeva.
I'm excited to tell you more about Aeries II. This sensor is a combination of 5 years of groundbreaking innovation by the entire Aeva team. We believe its unique 4D capabilities will accelerate the realization of the next level of autonomy, which is not possible with today's legacy 3D LiDAR sensors. Aeries II is our highest performance sensor yet. It can simultaneously deliver 200 meters range to a 10% target with a maximum range of up to 500 meters, 4 million raw points per second, and a 120 degree by 30 degree field of view, all while delivering the crucial fourth dimension of instant velocity per point, while still being completely immune to interference from other sensors or the sunlight. To meet the demanding automotive reliability and durability standards, we designed Aeries II from the ground up with automotive-grade ratings to ensure peak performance across a variety of road and environmental conditions.
The first thing you'll notice about Aeries II is its compact size. Our LiDAR chip module allows us to miniaturize many of the components that you see in today's LiDAR sensors. At 1/4 the size and weight of our previous sensor, Aeries II is suitable for a wide variety of applications from automated vehicles and trucks to industrial robots. And it can be integrated in multiple positions on a machine, as you can see with how it's integrated seamlessly into the grille of this vehicle. A powerful new feature of Aeries II is ultra resolution, which blends together the best features of today's sensor technologies: the 3D precision of LiDAR, the instant velocity of radar, and for the first time, resolutions approaching that of a camera. With up to 1,000 lines per frame, which is about 20 times the resolution of legacy 3D LiDARs, Aeries II with ultra resolution sets a new standard for the industry. To tell you more about this groundbreaking new feature, which we're introducing for the first time in the industry, I'd like to introduce to you Aeva's VP of Technology, James Reuther.
A unique new feature of Aeries II is ultra resolution. Ultra resolution delivers superior detail for static world, utilizing Aeva's unique instant velocity information along with our proprietary perception software. Ultra resolution on Aeries II provides an incredibly rich level of detail. As you can see in this driving scene, lane markings and traffic signs are extremely clear, and drivable regions as well as barriers and vegetations within the scene are easily segmented. Even fine details such as overhead wires are distinctly resolved by ultra resolution. Another important and challenging use case for safe automated driving is the ability to detect small objects on the road from a distance. Here we see how ultra resolution provides the ability to detect small objects on the roadway with superior detail that has never been seen before. As you see, from a distance of greater than 150 meters, we have multiple points on a small low reflectivity tire in the roadway. These points are enough for Aeva's perception software to identify and classify it as an object of concern, allowing for adequate vehicle reaction time. Without ultra resolution, the detection distance on such small objects reduces from over 150 meters to less than 75 meters. The addition of Aeva's per-point instant velocity, when properly leveraged, dramatically improves both dynamic object and static world perception for ADAS and AV applications. We are sometimes asked the question, what is the true value of velocity information? We at Aeva see two major interrelated advantages of per-point velocity. First is ego state estimation, and second is enhanced perception performance. With Aeva 4D LiDAR, while ego vehicle is in motion, we can measure the relative velocity for each point over the entire field of view. making it a simple process to accurately estimate the motion of the vehicle in all axes and in 6 degrees of freedom. In essence, Aeva's FMCW LiDAR provides an independent navigation solution without any other external sensors such as inertial motion sensors, GPS, or wheel speed encoders. This ability to estimate ego motion directly from the LiDAR point cloud has profound implications. First, Aeva's FMCW-based state estimation works even in environments where GPS is not available or in environments where there is no easily detectable features. This means the ego vehicle always knows where it is, even when driving in areas with poor GPS signals like parking structures or urban canyons, or where there are no features such as inside of a tunnel. Second, real-time state estimation allows for direct motion compensation of static LiDAR points. For example, to remove rolling shutter effects, which remain a challenge for legacy 3D LiDARs. Finally, the ego motion estimation process can be used in reverse. Given state estimation from the ego vehicle, the per-point instant velocity data allows for efficient and accurate online extrinsic calibration of the sensor. The main takeaway is that measuring the fourth dimension of velocity on a per-point basis turns the Aeva LiDAR into an alternate navigation state estimation device, providing important cost savings and better performance to our customers. Beyond motion estimation, per-point instant velocity information from Aeva LiDARs also dramatically improves perception. By measuring the instant velocity of every point, the Aeva 4D LiDAR knows which points within the point cloud are moving and which are static in real time. Aeva perception algorithms take advantage of this to provide faster segmentation of dynamic and static points and better overall detection capability for the end customer. In the case of moving objects such as vehicles and pedestrians, Aeva's perception stack successfully detects and tracks them with as little as 2 spatially adjacent and velocity-consistent points per frame. On the other hand, a perception stack utilizing 3D LiDAR point clouds often requires 5 or more points per frame to detect and track dynamic objects. The larger number of points per frame required for legacy 3D LiDAR systems is driven by their need to segment dynamic points from neighboring static points and to allow for enough fidelity to associate dynamic points from one frame to another, an extra step they all require to determine object velocity. Aeva's LiDAR, when combined with our perception algorithms, achieves significantly higher confidence for dynamic object detection and tracking beyond 400 meters, with the key detection metrics of precision and recall both above 95%. Beyond the advantages that the velocity channel offers, Aeva FMCW LiDARs impart significant additional benefits versus legacy time-of-flight systems. First, due to our FMCW technology, Aeva LiDARs are inherently immune to interference from the sun and other LiDARs, even other Aeva LiDARs, and are likewise free of retroreflected blooming, which is a crucial limitation of all time-of-flight LiDARs today. The result is a LiDAR system that provides for continually clear sensing and perception, even around bright reflective objects like traffic signs or strong illumination sources such as the sun. And when it comes to dealing with adverse weather conditions, Aeva's FMCW approach holds a clear edge. Aeva 4D LiDARs are able to punch through fog, rain, snow, and dust far more effectively than a time-of-flight LiDAR with equivalent range performance. When multi-echo returns are observed as a result of atmospheric obscurance, these are easily distinguishable from solid objects due to the variable velocities seen within such clouds. Thanks to our instant velocity measurement capability, we can simultaneously see through and filter out all points with such a velocity profile. At Aeva, our mission is to create the world's most advanced sensing and perception technology. Our unique 4D FMCW approach, paired with our breakthrough LiDAR-on-chip design, brings important advancements that will power the next generation of intelligent robotics, from self-driving cars and trucks to industrial robots and beyond.
Thanks, James. That was a great overview on Aeva's technology and shows how much work the team has invested into making Aeries II the most advanced 4D LiDAR sensor available. And now, I'd like to welcome Soroush and Mina back to the stage for some Q&A before we end today's event.
All right.
So we just saw some really great images of ultra resolution from James. So let's start there. Mina, how did we create ultra resolution? How does it work? And is it unique to Aeva?
Yes, actually today is the first time we're announcing ultra resolution, which really provides over 1,000 lines per frame and almost 20 times more than what you get on the market today. It's a very unique feature actually to Aeva's FMCW technology. It leverages three key advantages that we provide. First, the direct velocity measurement per point. Second, the ability to segment the dynamic and static scene without any compute power. And finally, the vehicle state output from our sensor, which provides 6 degrees of freedom without the need of any external sensors like IMU or GPS. We combine all of these advantages of Aeva's technology with our unique perception software to provide this ultra resolution in real time. Ultimately, this means for the end customer is the ability to see small objects such as a tire fragment or a brick on the road from up to 2 times further away, giving the vehicle more time to react and make safer decisions.
Okay, so other LiDAR companies have talked about their ability to measure velocity through their sensor data. Is this similar to or different from Aeva's technique?
Sure, I can take this one. So it actually is not. So with a typical 3D LiDAR, you take snapshots of an object as they're moving in the scene. Then you can try to calculate or infer the velocity between each frame based on a group of points. However, this really creates some problems. First, you have to detect the object in the first frame, and then you have to make sure that it is the same object, frame to frame, and track that over multiple frames. All of this takes additional time and processing power, which is also prone to errors in measuring the velocity. But what we do is quite different. We measure the velocity for each point directly and instantly. So our customers see this as a critical feature, especially for safety scenarios and applications where you need to understand where things are moving and what can be hazardous on the road so that automated vehicles can make those safer decisions faster.
So there's a perception out there that FMCW systems can't compete with time of flight because they have fewer points per second, which leads to lower resolution. Is this true for all FMCW LiDARs and especially for Aeva's?
So not exactly, because Aeva's technology is quite different from a traditional FMCW system. Now, traditional FMCW system provide lower number of points per second per beam, roughly 100 to 200,000 points per second. And this has been a limiting factor for competing with time of flight and has limited the adoption of such systems. What we have done at Aeva is we have developed a unique flavor of FMCW that allows over 1 million points per second per beam. And that has been in our product for over the last 3 years. On top of that, we have been able to break another key challenge in the industry for both time of flight and FMCW system, which has been the dependency between points per second and the maximum instrumented range. Typically, the longer the range you want to measure, the less number of points you can achieve. In our case, we can achieve 1 million points per second regardless of the maximum range we measure. This allows a dense point cloud at full maximum range, and that is what really makes ultra resolution possible.
So beyond points per second and maximum range and FOV size, are there any other characteristics to Aeva's LiDAR that make it unique?
Yeah, there are multiple advantages, actually. So first of all, we measure instant velocity, which is critical for providing high confidence detection of objects at long ranges, especially where you get to see a few points on an object. And this helps really with what's called clustering, which is distinguishing pedestrians, for example, from a light pole at over 300 meters. The second is we're free from interference, from sunlight, other LiDARs, or even our own Aeva LiDARs. Third is We have high sensitivity, which really allows us to achieve that ultra long range, performance of over 500 meters. And fourth, we've been able to put everything on a silicon photonics chip module, which allows us to manufacture at high volumes using proven technologies from telecom industries at volumes in the millions.
I guess maybe one thing I want to add to this is performance scalability. One of the advantages also of our technology is that with the same chip design, we can trade off range and precision. For example, we can set the range to 10 meters and achieve micron level precision, which opens up different set of applications for our technologies, such as industrial metrology, which very high precision is required. For example, this is the approach we are taking in our collaboration with Nikon to bring 4D LiDAR on a chip to the industrial metrology market. And we can achieve this using the same core LiDAR chip while adjusting our software algorithms.
What's the significance of this technology in the market, and what are you seeing in terms of adoption?
Right. There are multiple leaps with Aeries II for the LiDAR industry. This is the first time we have a 4D LiDAR based on FMCW technology that is built to meet automotive grade requirements, that is compact enough to be able to integrate it inside vehicles in a way that is non-obtrusive. And it's also built on silicon photonics technology that can achieve manufacturing scale. And this is where I really believe will open the door to accelerating autonomous driving programs where high performance sensing is crucial to achieve the next level of automation, including level 3 and 4 autonomous driving for both passenger cars and commercial vehicles, as well as for industrial applications. So we have made a significant production agreement with the autonomous trucking company Plus at the end of last year. And Plus is going to be also one of the first customers that's going to use Aeries II later on this year.
So we've heard a lot of companies talking about digital LiDAR and putting LiDAR on chips. Is this different or similar to Aeva's LiDAR on chip strategy, or how should we be thinking about this technology?
You want to take that one, Mina?
Yeah. So first off, one thing to highlight is we have to compare apples to apples right here. Some of the other LiDAR approaches are at a lower performance. They are not immune to interference or sunlight and cannot measure instantaneous velocity like Soroush was talking about. However, what we have developed at Aeva really is a breakthrough. We are integrating all key optical components of a LiDAR, including the lasers, detector, optics, onto this silicon chip module. This makes the assembly of the overall system much easier and faster, which helps enable mass scale production. This is quite different from what you typically see from others in the market who need to align multiple separate components individually at a system level, which ultimately ends up increasing cost and limits scalability.
Maybe if I add one more point, I think what is significant also for the end customer here is that this is the first time we have such a technology that is integrated at the chip level. And when really combined with this level of unique performance of our FMCW approach that Mina mentioned, we really think this will change the game of perception. And that's when you can provide a level of scalability at a cost that we think will be unmatched in the industry.
So on that thought of scalability, how do you plan to scale and mass produce Aeries II?
Right. So we've built a robust partner ecosystem in which we have gone through a thorough process of vetting our partners and selected some of the leaders in the space that have the capability, the skill set, and really the ability to scale to large volumes. And as I said earlier, we selected Fabrinet as a production supplier for our LiDAR on chip module. This module is at the heart of our technology, and we have removed all fibers from our system, which really makes it highly scalable. Now with Aeries II, which is really our B-sample design, we have locked our architecture and the final design for the system, which really puts us on track for achieving scale. And with this, we're working towards production in the 2024 timeframe.
So last question, when is Aeries II going to be available?
Right, so we're actually launching initial samples later on in Q2.
All right, that seems like a great place to wrap up the Q&A for today. Soroush and Mina, thank you again for your time. I appreciate you sharing Aeva's vision for the future of autonomy and telling us all about the brand new Aeries II. And for those of you joining us online, thank you so much. Stay safe and be well.